Welcome back, my dear students, into today's lessons. Feel free, as usual, to be together in the discussion as we've been doing in the past. So in case maybe still more of others who are just joining us this time in the discussion, please, I still more urge you to go back, look at the link down here. You may be able to calculate us, follow all the videos so that you be connected. You know much about logic. You cannot just start on the way, so please do so. But still more today, I will allow you to join us and see what we're going to discuss here. We are in the last part one section of our discussion in the topic about the irrational numbers and surds. And this today is just a matter of looking at one main idea in the irrational numbers and surds. Remember what we said that time? We are aiming at knowing how we can simplify the surds. So today we are looking at this objective here, where we need to know how we can divide the surds, and at the same time, we need also to rationalize the denominators. So which means division and rationalization of denominators work hand in hand. It's just one section. So today we will be discussing about the division of surds, but the target will be looking at issues on how we can rationalize the denominators. But now first, let me say something on what it means by rationalizing the denominator. First, let's have a discussion on the word rationalizing. A word rationalization is coming from the word rational. So here in mathematics, we talk of the rational. We are talking of a group of numbers which are in the form of A over B. So now by the discussion of today, where we would like to rationalize the denominator, it means we have some terms in surds which will be fractions, such that the denominators will be surds. Which means the denominators will be irrational. A group of surds are more of the terms which are irrational numbers. So when we say now rationalize the denominator, it's just simply making the denominator to have a rational number. That's our target. That's what we're going to do it here. So look at my chart here. I've just spread everything down very clearly. Look at this. So here we are, rationalizing the denominator, make the denominator of what? Irrational. Meaning that the number of the term of the denominator should be in the form of A over B. That's say you can manage to express it in the form of A over B, like that. Now, how do we rationalize that denominator, or say how do we make a number or say a term in fraction as a denominator to be irrational? Now that's an issue that we need to discuss here. Say for example, look at this. We may have a term like root of 2 over talk of maybe root over 7. That is a fraction. This is the numerator, root over 2, and this is the denominator, root over 7. So now the question will come and say, can you rationalize the denominator? It means the target will be the denominator which is in that form. If you look at the denominator there, you really see that that denominator is irrational. It's a surd. So if say now they say rationalize, it means here what we need to do is just a matter of making this term here, this term, the denominator, to be a rational number. That's it, rational number. Something like that. So if it being a rational number simply means that what we have there after rationalizing, it should be a number that can be expressed in the form of A over B as such. That's what we're going to do here. We are targeting denominators, not necessarily the numerator. Our interest is on the denominator. Now, we're wasting much of our time. I will be getting straight into the business to say issues about the rationalization denominator, to say how do we do it. Now, take this objective here. If you need to rationalize the denominator, this is the skills that you have in your mind. Make sure that you always consider the conjugates. That is to say, a denominator, when it's multiplied by its conjugate, the result will be a rational number. So which means here, like say here I've got root over 2 over root over 7. If I would like to rationalize this one to be in the form of rational number, I need just have to consider the conjugate of this one. That's the root of 7. The conjugate of root of 7 to be multiplied by that root of 7, the result will be what? A rational number. So simply without wasting our time here, let's master a simple concept here. That's each time I need to rationalize the denominator, let me just multiply the denominator itself by what? Its conjugates. That's why here I've explained to say multiply the denominator and the numerator. Of course, this is just by the normality, okay? Let's talk of the uniformity. When we are tampering up a term in a fraction, we need to consider the numerator and the denominator, but the target here is the denominator. So here you'll be able to multiply the denominator and the numerator by the conjugate of the denominator. When you do this, you really observe that the denominator turns out to be what? A rational number. Right. So here, let me talk of something again, though I already have written it out, that when you talk of the conjugate, what exactly that it is. If you talk of conjugate of surds, that time, as we discussed, we are talking of just the product of those two surds, and that to give you what? A rational number. So this have already been explained there, to say when you multiply two surds, it means that those surds are just the conjugates of each other, and then that you should have a rational number. So let's see what exactly does this one mean in a practical activity. So here I'll have some examples where we'll see us applying this concept that is here on the chart. Right, so can you take note of the following examples? We'll just only have 4 examples, but the one highlighted in red, I'll leave it for practice. So please, can you follow me very well how I'll be explaining the 3 first examples. Example A, example B, example C. But this one be left for your exercise. So now let's be together, see what I'll do for example A, example B, example C. Right. Just by way of look, you'll be able to see that the first one is a fraction, and the denominator of which is a surd. It's irrational. And again, coming here for the second example, we still have the same with the fraction. This numerator, this denominator, you see that the denominator is what? Is also what? A surd. It's irrational. And again, coming with this one here, we have got a 2-termed denominator, which have got a surd, which is root over 7, subtracting root over 3. So the entire expression is also what? Irrational. Right. So our attempt here is to change this irrational denominators into what? A rational number. Things like that. Right. So now let's see how we are going to handle that by the steps which are highlighted on the chart. Right. To say multiply the denominator by its conjugate. Right. So you can see here, we are talking about the conjugates. It means for those of us who are really following us yesterday's video, I think this is not very new to us. Right. Now, let's get into example A. These are now solutions. Right. For A, we are given 2 over square root of 3. Right. This is irrational. It's the denominator of this entire fraction. The question here simply asks us to rationalize the what? Denominator. So my explanation here, I've said, if you need to rationalize the denominator, you simply need to consider the conjugate of that denominator. If you talk of the conjugate, I'll come back for you to remind you, because here we are learning. It's just like another term in that form that can be multiplied by that denominator have it. So that that should be a rational number. So like here, if I may ask you, denominator here is root over 3. What can be multiplied by root over 3 in order to have the result as a rational number? Right. So that what will be multiplied by root over 3, that is the conjugate of root over 3. Right. So if you can look at that, you find that root over 3 can be multiplied by what? Root over 3 itself. There's nothing else that can be multiplied by root over 3 in order to have the result as a rational number. See here, the product of the two, it gives us root over 9. So if I take the square root over 9, obviously what I have is what? Is a 3. So 3 can be expressed in the form of A over B, which is just 3 over 1. Right. So it means in this case, The conjugate of root over 3 is root over 3. Right, so root over 3 is the conjugate of itself. So what am I going to do with that? So I'll have that one root over 3 and have it this way. Look at this. I'll take that root over 3. Let me write you for this here first of all. Conjugate, conjugate over a denominator, root over 3 is root over 3. Right, because root over 3 multiplied by root over 3 give us what? A 3, which is a rational number. So what I'm going to do now here, it will be something like this. Look, I'll take that root over 3 multiplied by a 2 on top. That's the numerator. And the sum root over 3 will be multiplied by what? The denominator, root over 3. Right, because we've already observed that, say, when I multiply the 2, that is a rational number. So that is my interest. So I have to do that. Right, we are also multiplying the numerator by the root over 3 in order to normalize up the what? The fraction. You can't just multiply the denominator. It means that you are violating the principles of the fraction. It's more like when you are simplifying a term like 18 over 24. What you do here, you divide by a common factor, which in this case is a 6. The result you have is 3 over what? A 4, like that. So if I would like to come back to 18 over 24, I will not just multiply a denominator by a 6, leave it like that. That will not be true. But I still also have to multiply the numerator by what? By a 6. So it will be 6 times 3 is 18, 6 times 4 is what? 24. So here we are targeting the denominator. But still more remember to observe the principles of the fraction. That when you tamper the denominator, by multiplying by a certain term here, you should also do the same on the top. So that's why here we're multiplying the denominator by by its conjugate. We also do the same on the numerator. I think you can be able to apply that knowledge by what good example I've just given you here. We have got 18 over 24. Right. So here we go. Right. So you multiply the conjugate of the denominator by the denominator itself, and also remember also to multiply by the what? Numerator. So let's see the result here. If I have a 2 multiplied by root over 3, I think we are also together in the previous video where we're discussing on how we can multiply a surd by a number. I think we will apply that knowledge now. That is not be strange to you this time around. Right, so I repeatedly say, if you are having no skills about multiplication, can you go back to the previous video? You'll be able to see what we've been doing there. So that knowledge is now applied here in the conjugate surds, where we are trying to rationalize the denominator. See, now we are multiplying 2 by root over 3. This will give us 2 root of a 3. The same like 1 is multiplying by 2 times a b, the answer comes into 2b. So they're considered like a b, that's a variable b, is more like a root of a what? Root of a 3. So these are just like unlike terms, so cannot be multiplied directly. Right. Then down on the denominator, what do we have? Root over 3 times root over 3. Right. So root over 3 multiplied by root over 3, what we have there is more like root over 9. Which sometimes you can just jump that step. You can just go straight into what? Just like root over 3 multiplied by root over 3, that's just a root over 3. Because the product of the root of a number by itself is just the number inside as the result. So here we have a 2 root of a 3 over, taking the square root of a 9, we have it as what? As a 3. Look at that, what we have it here. So this is our final answer. So if you look by comparing the original fraction, which is 2 root over 3, 2 over root over 3, and the result after processing out by what was highlighted on the chart as the procedure in rationalizing the denominator, you find that the two fractions are a little bit different. This one has got irrational number, a surd as a denominator, but this now has got what? Has got a rational number. This one has got irrational number, which is a surd here, but this now has got a denominator, which is a rational number. So in this case, it means we have managed and successfully rationalize the what? Denominator of that fraction. Right. So I still more at least come to you to remind you that, say, when you like to rationalize the surd denominator, please remember to multiply the denominator by the conjugate of that denominator. Right. So issue of conjugates we have already discussed it, and we all know it, what it means. Right. Can we now go to example B? Right. It's a little bit different from the first one in terms of the nature of the word denominator. Suppose we have got coefficient now, that's the 7 apart from 1, as it was in the first example, that is multiplying a surd. How do we go about that? Right. So can we go to example B? Right. So remember, as far as instructions are given, or set of the procedures are given for a particular operation, no matter what type of fraction you might have in surds, the principles remain the same. Right, you don't have to change the principles. So if we say you multiply denominator and numerator by the conjugate, that should be maintained, no matter what type of the denominator you have or what type of terms you have in the fraction, but the procedures should remain the same, don't change. Right, so for B here, we have a 5 over 7 square root of 11. Right, if you look at this, you'll find that if you look at the denominator, our surd is root of 11. That is our surd. And you can also call it as the irrational factor of the entire term is root of 11. So that now would be our target. How do we make it as a rational number? More like clearing out the root. It means that denominator don't want to have it as a root. So clearly, the teacher mentioned multiply the denominator by the conjugate. And then you also do the same with the word numerator in order to normalize up the processes in the fraction. So here, it means we have it. By the first discussion, you may be able to agree with me that if we target the root of 7, root of 11, a term that can be multiplied by root of 11, so that the result should be a rational number, should be root of 11 again. So I would take that and have it this way, 5 multiplied by root of 11 on the numerator, look here. And again down here, I'll have my 7, root of 11 multiplied by root of 11. That's the way to go. Right. So here, if we proceed in the simplification, it'll be like it was in the first example. Nothing much. So I have 5 times root of 11. What I get here is 5 root of 11. Right. Down there, you also have the result after you take the product of 7 root 11 by root 11. This one, I already explained earlier to say when you're multiplying root of a number by itself, the result is just the number inside the root. Like root 2 multiplied by root 2, the answer is 2. Root 5 multiplied by root 5, the answer is 5. Right. Instead of saying root of 25, then you come in and get again square root of 25. That extends up the processes in solving in mathematics. Right. So yes, at least some of our students have to apply the knowledge as quickly as we can. Right. So here it means we have 7 multiplied by 11 down there, because we have got 7 root 11 multiplied by root 11. Right. So root 11 times root 11, the answer is 11. So here we go. On top 5 root of 11. Down here it will be 7 multiplied by 11. The answer is 77. Right. So look at this one, the way we have done it, and how we have processed it out in order to come up with what? Solution, which is this one here. The same, compare the first fraction as it is here. It has a what? Irrational factor, root of 11, which is just a surd. But now if you look at the result here, after we have done that process, multiplying numerator and denominator by the conjugate of root of 11, we are able to get the result on the denominator as 77. So 77 is just a rational number. So it means here we have also successfully managed to change the denominator into a rational number. Right. So you can see it's just simple and very clear that you students, I think you don't have even to struggle much in topic 1. Moreover, all the topics in mathematics, I don't see anything that is difficult or say a problem. But the problem is you, because you are failing to handle things like not most of the times patience. So think this time around, you can see the type of mathematics. These are the type of maths that will also give you some kind of homework when it comes to exam. But now ask yourself, why should I fail such type of maths that time? So the only solution to that, do much of the practice. As much as your head is used to such type of concept, like they're going to get past with distinctions. Right. Can we now finalize our discussion with example C, which is quite different from the rest there? Right. In the sense that if you can look at the first two examples, they have got denominators which have got a single what? Term. But in this case, we have got a denominator which has got what? Two terms. So just like now, if I've got a denominator which has got two terms, how do I handle it? What is the same principle going to work? Where we're saying that we have to multiply numerator and denominator by the conjugate of that denominator. Is it going to work, or maybe we're going to change? My answer is no. The principle remains a principle. It's more like a rule which has to be followed. So you still have to go by the same here. Right. So I've not changed anything. But what we just know here, other operations will just come in automatically. The things which I've already discussed. So here it's just a matter of getting to know much on how you can multiply the surds, addition of surds, subtraction of surds, they all come in. But the principle remains the same. Multiply the numerator and denominator by the conjugate of the surd. So if you know the conjugate, no problem here. So let's get into business. Right, so see, here we are. We have square root of 7 plus c square root of 3 over square root of 7 minus c square root of 3. Right. Let me have this part here to clear up the space for discussion to this one. Aha. Now, here if we look at the nature of denominator, it's got two terms. So now from the earlier discussion that's in the previous video, if we were together, but if you weren't there, I will just aid you, just get into the link down here and see how we can come up with the conjugate of this type of what? Expression, where we've got two terms. The first one here is clear. You just take the conjugate, which is just like the term itself. You multiply root 3 by root 3 is 3, it's rational. Root 11 by root 7 is 11, it's rational. But here now, so here, I'll take you into that other form that I highlighted on the board about the difference of two squares, where I indicated, where if I've got expressions in the form of a minus b multiplied by a plus b, the result of that form is always a rational number whenever it comes into issues about surds. You see? So now here it means, if you remember about that, this won't be a problem. So what it means here is just like yourself, you have just to ask yourself to say, what could be the expression that can be multiplied by this one in order to have the result as a rational number? Right. So usually, if we have got a process of this kind here, remember that the rational number will always come in after you have done the operation in expansion of that and that. So if I've got the same terms in the two brackets, this one will always give you a squared minus what? B squared. A difference of what? Two squares. So it's about the difference of two squares coming from this format. Either one takes us in the rational number. So when I see this, it's as good as I see this one here. So to a mathematician, you'll be able to at least, based on the previous discussion about this type of presentation, you can be able to apply knowledge here. To say, if I would need again here to have the conjugate of this by this explanation here, as we discussed that time, to say when I say a minus b, what can be multiplied by a minus b in order to have a rational number, we are able to multiply by the same kind of expression, but different in terms of the signs. So it should be a plus what? Plus a b. And this format always will take us into what? A squared minus what? B squared. So it means the same, in our case, we are going to convert this one into a different form, which should be this one here. But this will come in only when we consider the conjugate of this. So it means the root of 7 minus root of 3, the conjugate of which is just like the way we have done here. If I have a minus b, what could be multiplied by a minus b in order to have a different two squares? That will take me into the what? A rational number. It should be another expression which is a, but now with a different sign plus b. This is regarded as the conjugate of this, then in our case here, the same, we may regard our root of 7 as A and root of 3 as B. So if somebody asks me what the conjugates of this, then the conjugate of root of 7 minus root of 3 is root of 7, then now it should be plus root of 3. Right. Because we're playing from this format here, which takes us to difference of 2 squares, and the result of this is what? A rational number. If we talk of issues about the what? The surds. So now it means we'll go by that. So what we do here is just like the first there, we also do the same and rewrite into that format as we did earlier to say, much that I know that the conjugate of this is this one here, root 7 plus root of 3. Then now I'll come and write it here like this. On top here is root of 7 plus root of 3. That's it. By the principle that says you multiply denominator and the numerator by the conjugate. It means that numerator should also be multiplied by root of 7, then now minus root of 3. That's it. Look at that. Then now on the denominator side, what do we have? We also write that one as the root of 7 minus the root of 3 multiplied by the conjugate of this, which is this one here, root of 7 now plus for this part here, the root of 7 here, we have root of 7 minus root of 3. So it means here the conjugate is plus c. Sorry, for this one here should be plus here. Right. So here should be plus c root of 3. Look at that. We're changing nothing here. Conjugate of this one is just the same terms but with different signs. So conjugate of this root of 7 plus root of 3. If here there was plus, it means the conjugate would have been a negative with the same terms here. So that's the way it goes. So you can see that what we've been doing with the A, B are not very different. Here it's just a matter of trying to know how do we find the what? The conjugate of what? An expression in 2 terms like that. So a good guide is the same which I've already said about the A minus B. The conjugate of which is A plus what? Plus B. That takes us into what? Difference of 2 squares. So that simple skill is good, is just there for you to help understand the conjugates of the what? Of the surds as such. So once you're done with that, the rest of the business is just the historical part where you just have to expand where necessary you go. But where you have got maybe a simplified form of expansion, as a mathematician, you can apply it. But where you don't, or maybe you have got a problem with the other methods, just go it direct. Because this knowledge, as you can see, the brackets, the way they have been expressed there, it's just like a simple method that we've been doing in what? In Form 2. You just expand up the term there by multiplying, like here you talk of terms in the first bracket, multiply by the terms in the next bracket, terms in the first bracket, multiply by the terms in the next bracket, and then that you get that the answer. And you really are going to observe that the denominator will be a rational number. Right. But now, when we are trying to simplify, like say denominator in this case, remember what I said. If we have got A minus B and A plus B, this one is just simply having a difference of what? 2 squares. So here I don't expect a student like yourself who is an intellectual in mathematics to go for that process of having this times this times that, and then this times that, this times that. Yet you know these are conjugates of each other on this category. And this category gives you difference of 2 squares. Meaning to say if I write like this, it's as good as writing like that. So as a mathematician here, why don't you just rewrite this one in this form? Maybe on top here, you cannot write like this. Because this expression on the top does not suit this. You can see here, though we have got root of 7, root of 7, root of 3, root of 3. But now you can check the signs are the same. So which means if you multiply that by that one, cannot go by this one. You can't have difference of 2 squares. So this one, whether liked or not, is where now you can go for the normal expansion process. This will apply you this multiplied by that, this multiply the whole of that expression. But here you are free. You can still take the same method, but it's wrong. Just go for the shortcut, just square this one as we're squaring A, square the 3 as we're squaring B, because that will be the result when conjugates are multiplying each other. Right. So let's get ourselves through that. So which means on top, I'll have root 7 here, multiplied by this bracket, which is root of a 7 plus root of a 3. Then root of a 3, which is positive root of a 3, multiplied by root of a 7, then plus root of a 3, like that. Over here, we don't have trouble step like that. Let's just square the root of a 7. Then we subtract root of what? A 3, like that. That's the way it goes. Right. The rest of the story, just continue processing out like that. Just simplify until at the end what you have is the answer. As far as there are no further simplification in the steps, then that is your answer. So like in this case, I don't think you can say this is final, because you can see there are several areas that one can do simplify. So we begin by multiplying this one by this to remove the brackets, and we're going to operate the issues down here. So here, root 7 multiplied by root 7, we have got what? 7. Because this and this will give us root of 49, which is what? Root of 49 is just a 7. So I say that the mathematicians sometimes other steps you can go it directly. You don't necessarily to show everything on the paper. Right. Root 7 times root over 3 terms in the roots multiplied by themselves. I think remember what we've been doing in the multiplication of surds in the previous video. Go back if you have forgotten that. So root 7 times root 7, now it will be 7 times 3 inside. That one will give you a positive root of 21. Had it been like they're going to get a perfect number, I would just written that number without a root, as it is for root 7 times root 7. We have root 49, which is a perfect number. 49 give us 7, but for 21, we don't have that. So which means we leave this 21 in the root form, like that. Then we go to this other part of the brackets, where we need to expand root 7, root 3, and root 7, then root 3 again. So it'd be like root 7 multiplied by root 7 multiplied by root 3, it still more comes in positive, root of 21. And then root 3 times root over 3, that one will give us a perfect number, which is what? A 3. Because you get what? A 9 from that. Root 3 times root 3 gives you in root 9, and that root 9 is a 3 if you like to go direct. But omit such type of scenarios at times. So coming down here, it means now talk of issue about the denominator. It's just simple. You take the square of a root of a number, root of a 7. So if you take the square of the root of a 7, is this as good as just having the answer as a 7? Where it is coming from? There is just like you have root of 7 times root of a 7, you get root of 49, and that is 7. So as mathematicians, at least somehow of this type of presentation, we don't have to waste time writing a square root over 49 and then you get square root of 49, then a 7. No. Just have a root of a number if it is squared. The answer is a number inside the what? The root. Right. So the same, it applies here, where we have got a root of a 3 squared. So here it be minus, and the root of the 3 squared, the answer is just what? A 3. Right. Now, after I've done this, what is next? It's just as I said earlier to say, it's just historical part. The rest of the steps are just like history. That's just self-explanatory. Like here, what is needed now in order to wind up everything, you have just to work on the like terms if they're there. But if they're not, then that's the end. That's your answer. So if you can now check on the numerator, we'll find that 7 and a 3 are like terms. So in this case, it means I can simplify 7 and the 3 by addition type of operation. So I'll have 7 plus a 3, that gives me a 10. And if you look at this side and that side, by what we discussed in that other previous video, where we are looking at the like and alike surds, we said that the surds which are alike can be recognized by the irrational factor. Do they have got the same irrational factor? If they are, then it means those are like surds. So this situation we have here, we have got root of 21 is irrational number, root of 21 irrational number. It means the two already are in the form of the same irrational factor. It means of root of 21 and root of 21 are like terms. So this is as good as having like a plus a, and what the end you have together is just like what? 2a. So the same way it be root of 21 plus root of 21, the answer should accompany a coefficient, which is a 2 over 2 root of what? 21 as such. Now, down here, we have our 7 minus 3. The answer 7 minus 3, that one gave us a 4. Right. So when we reach at that juncture, you can see that now the denominator has already been what? Rationalized. We've got the rational number here. See, earlier we had root 7 minus root 3, but we're no longer having root 7, we are no longer having what? A root on the denominator. We have what is the what? A rational number, which is a 4. Right. But before you conclude that this is your final answer, we do that. If there's nothing else you can do in that what? In that fraction. Suppose like we have what we have been doing in the vulgar fraction of numbers, like say maybe you are solving a certain fraction, a summing fraction, and the answer comes in like say for example 6/12. You cannot conclude that way to say this is my final answer. No. As far as sometimes if there's a common factor that get into the two numerator and denominator, you are always able to simplify that. So like here it means you come and divide by common factor that get in 6 and what? And the 12. You have what is like here is 6, 6 here 1, 6 here 2. So this one is simplified into half. So the same here in Surds. This is about maths in application. This has also to apply here. Do you have a common factor on top here that can divide into down here? That's in the denominator. If it is there, do it. If it is not, leave it there. But if you proceed, you'll be denied some marks in exam. It means you have not finalized it. So now for us to identify if the two are numerator and denominator have got a common factor, you can introduce an issue about factorization. More especially where we have got more than one term. Where we've got more than one termed expression. Like on top I've got this and this one. So if I look at 10 plus 2 root 21, this one, we'll be able to see that we have got a common factor that can get here and here. So what you do, you need to factorize that one out. If it is not there, then don't do anything to that. Leave it. So if I look at this and that one, you find that there's a common factor which is a 2. Then now I'm going to factorize that one out. So what I'll have here, it'll be 2, open bracket, 2 into 10, give us a 5. 2 into 2 root 21, it means the 2 just divide into a 2, and that is 1. Term that one, root of 21. So you have got plus root of 21. Like this. Right. Why down here, what do we have? It's a 4. 4 is just like a single term. There's nothing we can do with a 4. We do not even necessarily think of what? Factorizing that. Right. So now, having done that, as we had earlier, what I showed you about the 6/12, I was dividing by common factor, numerator and denominator. The same way, check after factorizing the numerator, do I have a common factor? Maybe possibly can cancel with the denominator. So presentation of that kind will also say yes, it is there. Here we can see a 2 is multiplying by this one. So here it means we are going to divide a 2 into a 4. So just like common factor for the numerator and denominator is a 2. So you divide 2 here, 1, 2 here is 2. Right. So the one you get here is just like the one that is multiplying by the whole of this one expression. So if 1 we have it here is multiplying by this, because it's more like expanding here, you have what is 5 plus root of 21. And down here, the 2 gets here is 2 times. So it means here down here you have got an answer as a 2. Right. So when you look at this one and this one here, they're almost just talking of the same, only that this one is a simplified form of this fraction here. Right. So please always remember to do that. Check if there's a common factor. And such things of say, like it is here, you say just a 2 dividing here, that thing does not exist in mathematics. You always have to factor out because this is one expression. You cannot violate it that way. So always when you want to check for the common factor, try first of all to do the factorization and have it as we have done here. Then the number that is after the bracket here is free to factor with the number on the denominator side. So this is our answer. And we have got our rational number, the 2, on the part of the denominator for this one here. Thank you very much for that. So still more, before I leave the stage in this video, I would still just like you to at least have a try exercise which has been highlighted in red. Like try to rationalize the denominator of this fraction. Right. Student, what we have in the other video, it'll be just like the application of what we have just learned here. to say like where possibly can you apply the information that we have done here. Like, so in the next video, what we do, we'll have some discussion on some problem that will need some application of what? Of the Surds. So what I ask you, please, you need at least to take that initiative. You go back like from the starting point where we had our first video, try to at least follow all those videos by the link that is down here, so that whatever we're doing here together with you should be logical. Like, you should not just start from the way, because you may be having a lot of questions. But if you study together, that's very much. And I hope that you have got the skills where we were discussing on how best we can simplify the Surds. So all objective that we have had, they're almost done. Right, so don't leave me alone in the last video that we have for this topic. Let's try to see the areas where you can apply the issues about the simplification of Surds. Thank you very much for that.